Hey everybody, Lars here. Time for the second review video for Unit 2. Tonight we are going to look at loops, and loops are a very important thing, and they're very powerful, and they're going to allow us to start solving some real problems and start moving along as far as taking basic Python skills and actually doing something real with it. And you're going to see after we do what we need to do tonight, the next video that you're going to get in this unit is going to introduce you to a site called Project Euler. And that, as I think I alluded to in the last video, is going to be a site with a whole bunch of number problems, and we're going to use Python to attack some of those number problems. But first, I have to get you loops, and it's the second half of Unit 2, and it is incredibly powerful. I have not set anything up, so we are doing everything from scratch tonight. But that shouldn't be so bad. Let's go grab a file. Let's put some comments on the top. I'll just say this is a comment. And then I'll say author Lars. And I'll say play around with some loops, and we will get naming it out of the way. So let's just say save as, and I'm going to jump up here, and I'm going to go to my, where is it, Python Data Science, and somewhere I got a fall 2006, and I have not created a Unit 2 folder yet, but in Unit 2, I'll just call it loops, loops.py. So now when we do something, we should just be able to save it and run it. Let's see what we get. Okay, and we're good to go. All right, great. All right, loops, 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 loops. Let's look at the simplest thing we can do with loops, and then slowly but surely build things up. The first thing I'm going to do is I'm going to create a list, and I'm going to create it on the fly. I'm going to open it up with my brackets, and I'm just going to throw integers in it. Okay, not braces. You want to make sure, thank you. You want to make sure you have brackets. Is that a bracket? I believe it is. Okay, so then we have my list, actually MT list, my list. My voice sounds low. It's because I think I'm coming down with a cold. Probably has something to do with getting up and hauling down to the Rutgers game today and sitting in the wet and then the sun and then the wet. Let's see, print my list. And you'll see when we just print the variable, we get our list. 2, 4, 6, 8, 10. That's great. Okay, now iteration or looping is real easy. What we need to do is we're going to set up a programming construct where you're going to regard every single item in that list and do something with it. The way we classically do this in programming is with something called a for loop, and Python's no different there. It's different in a lot of other ways, but here we also call it a for loop. And what we would do in this particular case is set up a loop that just iterates over the list. And what you're going to find out about Python is that that's how iteration is handled. Python always just iterates over a list. In other languages, C++, Java, most other languages, you set up a for loop where you set up a variable that you use, and then you have a condition that you wait for the variable to meet, and then you'll increase it by 1 or decrease it by 1. And that's kind of the way you set up your loop. We don't do that in Python. In Python, you always iterate over a list, basically one thing at a time. And what you're going to learn is in order to manipulate the way that you iterate, you really want to manipulate your list. So we're going to do the easiest thing we can do, and I'm just going to say for I. Usually I is used, I think it hails from math. I, J, and K are usually the variables used when we loop. Some people think I means index. Some people think integer. I, to be honest with you, don't have the first idea. But we usually use I when we first start creating for loops. So I'm going to say for I in my list, and that is it. Then I'm going to put a colon. I'm I'm going to hit enter, and you're going to see idle has indented 4 for me. That's because when I put that colon there, I'm going to create what's called a code block. And the first thing I'm going to do is really the simplest thing we can do is I'm just going to print I. Okay, so I'm going to run this code. I have a list, and I'm going to say for I in my list, which means every item in the list, perform these actions. Now you'll see in a second that I can add to this, and everything in the code block would be run for that particular value. So what's going to happen is the first time through the loop, it's going to say for I in my list. So the variable I is going to point to the first item. I'm going to print the first item, no more code. So we go back to the beginning. For I in my list, it grabs the next one. So the second time through, I equals 4. Prints 4, go back to the top. It's going to be equal to 6 until it gets to the end. And Python can realize what the end of a list is, and then you just drop out and come out here in the code. So if I just run this, you're going to see over here, I just list the code. But a lot of times when people see loops for the first time, they think, oh, this is just for listing things. It's not. You want to perform tasks. So we can, let's say I want to square it there. And just to show you that you can also do other things in a block. You don't have to do just one command. You can have multiple commands in a block. So now when I start the loop, I'm going to grab the first item. It's going to be I. I'm going to print 2, 2 squared, 4, and then underneath it, you'll get an 8 because you'll have 2 to the third power. Okay. Then you go up to the beginning. For I in my list, you grab the 4. You do all of the commands. You grab the 6. You do all the commands until you do it for the 10. And then Python realizes you're at the end of the list, and you jump out to the bottom. Let me show you what happens when you jump out at the bottom. I'll just say the end. And that's it. That way you're going to see the loop will run, the loop will run, the loop will run. That's kind of why it's called a loop, because it goes up and down, up and down. And then when it's all over, boom, I'll just print the end once. So let's see how this looks. Okay, so you can see how that works. For I in my list, grabs the 2, print 2, then 4, then 8. Go back to the top. For I in my list equals 4, 4, 16, 64. Then it grabs the 6, 6, 36, 216, until it goes all the way to the end and grabs the 10, 10, 100, 1,000. Then it tries to go to the top again, and it realizes, hey, there's nothing left in the list. I'm done here. And then it goes to the bottom, drops back to this command, and just says the end. Okay? So that is the basics of iteration. It's when you have a list and you basically set up a block of code to be run on every item in this list, and then you just set up the list construct and have it go over everything. Boom, 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 boom. Very simple example. You're going to see later that list can contain 1,000,000 items. And the thing about computers that makes them great is that they're stupid. They only do what we tell them to, but when we tell them to do something and we tell them to do it properly, it does it incredibly fast, and we're going to learn a lot more about that along the lines. We can actually, I'm going to show you how to time things later in the course, and you'll be able to see just how fast computer processing can deal with numbers like this. All right, so I am now going to look at, and I'm going to put all this code up for us, so don't worry about it. Don't think you have to type away and do all that. I'm going to save it all. The second thing I really want to show you with lists is, if you have some experience, and like I alluded to before, I know a lot of people in this class have experience programming, so you already know how to set up for loops in Java or set up for loops in C++ or some other languages. Usually, you'll just say, give me a variable I, and keep looping until I is greater than 20, and every time you loop, make I ++, or make I, equal to 1, or blah, blah, blah. We don't really do that in Python, but because it's such a common programming task, I want to loop 20 times, I want to loop 40 times. It's called a definite loop. You know how many times you're going to use it. In the beginning example, we knew we were going to loop 5 times because that's how many items were in the list. These are definite loops that we're dealing with now. We'll get to indefinite loops in a little bit. So what if I wanted to go do that classic loop where I just iterated over something 10 times? I can do that, but what I need to do is create a list of 10 items first, and I can do that pretty simply by just saying for I in range, and then I say 10. Okay, so give me a range, And that's the default where you just put in the ending number. And then I'm going to print I, and we're going to see what we get. We're going to explain things. So you can see I print 0 through 9 because remember, we're computer programmers, so we start counting at 0. So you might say, okay, I said 10. Why didn't I get a 10 down there? You didn't, but you got 10 items. You started counting at 0, and then you ended with 9 because this is the dirty little secret. That's kind of shorthand what you're looking at right there. What we really just ran is this, okay? That says range, start at 0. Remember, it's an interval in Python, so 10 is the first thing I don't want. So I'm going to get from 0 to 9, increment by 1, all right? The default is you just have to put a 10 there, and range will understand you probably wanted to start at 0, and you probably want to increment by only 1 because it's very common. And you'll see when we run this little piece of code, well, it's the same thing, okay? But knowing this, we can now start playing around. Let's say I wanted a classic count from 1 to 10. I could do that. 11 is the first thing I don't want, and I want to start at 1. So now when I rerun it, I go from 1 to 10, okay? Now, nice little secret here. I think I go 10, 0, first thing I don't want, -1, I can go backwards. And then you can see I get a classic countdown from 10 to 1. Boop. Because this allows you to go backwards as well as forwards. If I put a -1 there, then the loop will go backwards from the larger number to the smaller number. Another thing we can do with loops is I'm not going to go backwards anymore. I'm going to go from 0 to 101. Get used to that because I want to go to 100. And this time I want to increment by 5. So now when I print my list, I get the multiples of 5. Okay? So range is kind of how we create number patterns to iterate over. If I know I want to do something 20 times, I'll go from 0 to 21, and boom, I'll get my 20. Okay? One little piece of behind the scenes here. People think, oh, okay, up here I said for I in my list, and that was the list. So range must produce a list of those numbers. It doesn't. Range is kind of a special thing in Python. It's not a list. So the numbers from 0 through 100 by these intervals are not sitting in a list somewhere. Range is what's called a generator. It's something that saves memory by just generating the next number in a sequence and then dropping off all the other numbers. So as we go along, range remembers where it was and dump things off. There is a way to use range to make a list, but we will, I think I may have showed you that in the slides, but we'll deal with that later. So that's how range works. Know that you can have a plain range and just, just put that 10 there and know that you're going to get 10 items and you're going to start at 0 and go from there. So 0 through 9 is that, but then you can also remember that you can give it a starting point, you can give it an end point, and then you can give it a sign to increment, and there you go from 1 to 10 again. Okay? All right. Then I will leave that there so you know a little bit about range. And then one final thing I'm going to do is attempt to do something semi-useful. Now that we have loops under our belts, we know how to iterate over lists, and we know how to use range a little bit, you'd be shocked. Now we have something powerful that we can use and make our computer program start doing things for us. So what I always do as an example is I say in the first 300 natural numbers, I'll just go in and find the squares greater than 50,000. Okay? So somebody comes up to you and has a problem. They say from numbers 1 to 300, if you take them and square them all, how many of them are greater than 50 grand? So I've got to solve this problem. I've got to solve it with the Python skills that we've gotten in the first 2 units. So I've got some data. I know how to deal with strings. I know how to deal with some arithmetic a little bit. I know how to do if-then. I know now about loops. I know now about strings and lists. let's see what we can figure out. So the first thing I'm going to do is I'm going to say, okay, well, let's try and make my range thing work, Marie. For I in range, let's say I want to start at 1 because that's the first thing I want. 301 is the first thing I don't want. And I want to go by 1. I don't have to put it, so I can just put that. And just to know that I'm doing the proper thing, I'm going to print I. So let's run this and see what we get. All right, I get a list, and if I were to run back up here, I see I start at 1 and I go all the way to 300. So that's a pretty good deal. So now I know I can list 1 to 300, but I don't really want that. I want the squares. So let's square them. And then we get the squares. Okay, I can see there's a bunch of them greater than 50K, so that's a pretty good deal. And I come up here and I say 1, 4, 9, 16, 25. So I am indeed getting the squares. All right, now I have that. But that's not what I want. I want to find the squares greater than 50,000. So I kind of found them because I printed them out. But what I really want to do is count them up and have them in a list. So I think what I'm going to do with this is set up a list. I told you we use them a lot. I'm going to call it squares. And I want it to be blank. So here's a little secret for the first time. You get to see that. If you want a blank list, you just say squares equal bracket, bracket. And it'll give you a blank list. Okay. So now for I in range 1 to 301, instead of printing I squared, I'm going to put it in my list. Let's see. Squares dot append. You remember append from the last video. And I'm going to append I squared. And then at the end of the day, I'm going to print squares. See what I get. All right, look at that. Now I've run the numbers using range, and I've appended it to my list. So now I have a list, 1, 4, 5, of all of the squares from 1 to 300. So we're making progress. Now, you might be saying, well, that's really just a different way of listing it or a different way of, sending it to the screen, but it's not. It's in that list now. And because it's in that list, I can play around with it. I can iterate over it. I can do different things with it. And that's what we're going to do right here. Forget print squares. Now I have a list, so I can take a look at that list and see what is greater than 50,000. So what do I want to do? How do I want to do this? I think I want to iterate over the list. So I'm going to say for I in squares. Remember, we don't need range now. I have a list, so I'm going to iterate over the list. I don't need to play around with range anymore. I have it. The first thing I want to do is say if I is greater than 50K, colon, start a block, print I. All right, that should do the trick. Let's find out if it does. All right, where did we start? Yep. Okay, we look good. Now, I've squared my numbers. I have a list with squares, and I'm looking at all the ones greater than 50K, but I don't really know how many of them there are. How would I find out how many of them are? Let's think about this. I think I know what I'm going to do. I am going to do something called a counter. What I'm going to do is I'm going to set up a variable on top of the loop here. I'm going to make it equal to 0. And then when I come down here, I'm going to make count equal to count plus 1. So it's 0 here. First time I'm in the loop, so I'm definitely dealing with something greater than 50,000. The first time I look at it, I'm going to add 1 to the count variable. Okay. Now I had to create it up here because remember that we evaluate equations from right to left. And if I didn't do that, I'd be using a variable I hadn't defined yet. So Python would go, no, we don't do things that way. It's okay if the first time it sees it is here and we assign, okay? But if you start using it in an equation and you haven't defined it yet, Python says, no, you can't do that. Not good, not fair. So I define it up here so I don't run into that problem. And now if I just want to add 1 and always maintain the value, I can say count equals count plus 1. So as you can probably imagine, if you come into this and count equals 3, then you add 1 to it, then you're going to assign the value 4 to it, and you're always going to keep track of that. So let's do that. Let's print count. And what I'm going to do is I'm going to print it incrementally. So as we go down that list, I'm going to see what number everything is. Let's show you if that works. And it does. And look at that. We have 77. So of the first 300 numbers squared, 77 of them are greater than 50,000. So that kind of answers our question. So is there anything else we can do here? There's actually one more thing, which you might find interesting, is that we can add things up as we go along. And we do that with something called an accumulator. And it's pretty much the same idea as the counter. But when I'm doing a counter, I want to know how many times I'm looping around there. So I add 1 to the counter. With accum, to accumulate something, what do I want to add? I don't want to add 1. I want to add the item itself. So I'm going to add I. And then I'm going to print accum so that I get a rolling total as I do that. Let's find out if we're in good shape. And we are. Okay, so now I'm printing out all of the squares that are greater than 50,000. I'm numbering how they appear in the list, and I am accumulating them. So when I finally get to the end of the list, I can see that the 77th square greater than 50K is 90,000, and if all of them are added up, I get that number right there. What's that? 5,323,626. Okay? So that's a way we can take what we know about lists and what we know about loops and what we know about, decision structures and actually do something with it. I mean, it might not seem like the greatest shakes in the world, especially if you've had some experience doing that stuff. But if you think about it, what's today? Today is the 25th. We only started this class like 3 weeks ago. And already with code like that, you're answering a problem. Because think about it. If you didn't have a computer in front of you, how would you answer that question? Right? Most of you would pop your computer open and stick it in Excel and start doing, things with Excel cells and figuring those out. There's heuristics you can do too. Like you could square 200 and say, okay, that's, not going to be greater than 50,000, and boom, 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 you'd find the first one that was. But what if you wanted to add them together? You'd have to square them all and sit and add them together. And now you don't have to do that, because when you have a programming language under your belt, you can go and codify the logic like we did right here and do something simple like that. Logic like this, you're going to do this in 10 seconds once you get some experience. Something like this, you're going to do that in the interactive window. You're going to use a command line for this. You're not even going to have to program for this. This is easy after you get the hang of it. So this is actually something meaningful. We set up a list. We used range to create the numbers from 1 to 300 and put them in a list. Then we iterate over that list down here. And if a number is greater than 50,000, we click a counter and we add it to an accumulator. And then we print as we go along. So that's, now you can actually do something. This is the beginnings of data science. You're going to be storing things in lists, and you're going to be regarding lists and determining if things meet certain criteria. And if they do, you're going to accumulate them or count them or stick them in lists so that you can use them later down the line. This is the beginning. These are the beginning tools that are going to allow you to basically take your data and start putting it in formats that you find useful for the other things you can be able to do with it. All right. So that is that. Like I said, you're going to have all of this, so zero worries. I do want to go over 3 more things. And the first thing I think I'm going to do is show you something called a nested loop. I'm going to say for I in, and then I'll say range, and I'll make it simple. Make it 3. And then I'm going to print. How about putting quotes? Just before I jumped in to create this video, I popped into forums to make sure everybody was happy. And somebody, I can't remember who, I'm sure I'll answer it regardless, put in that Python allows us to use either double quotes or single quotes. That is absolutely true. The only thing is that you have to be consistent. If you use single quotes, then you have to keep using single quotes. And the reason we do that is so that in our strings, we can use double quotes and single quotes. So if I want to use a double quote in a string, I just use single quotes on the outside. And vice versa. If I want to use a single quote inside of the string, well, then I use double quotes outside of the string. All right. That's why Python allows you to switch back and forth from that. It doesn't matter. It doesn't care. The only thing you ask is that you're consistent. I switch back and forth arbitrarily. I'll be honest, most times I use double because I'm an old fuddy-duddy and I'm used to using double quotes when you do strings because that's what you do in a lot of other programming languages. But single quotes are fine. They work absolutely fine. As a matter of fact, single quotes is the default for Python. Because if you go to the interactive window and examine your strings and print them out, you'll see that they're bounded by single quotes. So you probably want to do the single quotes. But I digress. For I in range 3, print outer 1. Now, what's my next line going to be? For J. Now, I'm running that I up there. So the loop's not over. I don't want to reuse the same variable. So classically, in looping and computer programming languages, we use I, J, and K. I don't want to mess with tradition. I don't want to anger the computing gods. So I'm going to use J and show you J as well. And I'm going to say for J in, and I'll say range 5. And then I will say print, and I will print inner, and then I will print I and J. Okay? And that looks pretty good. So what is that? 4 lines of code? Look at that piece of code right there. Now watch it run. Bloop. Okay, we're going to take a look at this because I want you to see how this works. This is called a nested loop because we're running a loop inside of another loop. And the way I demonstrate that here is I say for I in range 3, so I becomes 1, print outer. Well, it becomes 0 because we start counting at 0. We are computer scientists. And then I go down here and I start a new loop, still running inside the outer loop. I say for J in range 5, print inner, and then the I and the J. So you see that's exactly what we do. We do it 1, 2, 3, 4, 5 times. Okay? Then after this thing runs 5 times, that loop ends, and we go back to the outer loop and grab the next value in that. So the second time through, I is going to equal 1. So what do we print? Right there, outer 1. Okay? And then we go to the inner loop again. And 1, 2, 3, 4, 5, that runs 5 times. So you see inner 1, 0 through 4, because we run it 5 times. Then when that loop's over, we go back to the top. And we say for I in range 3, we get the last one. That becomes a 2. We print outer 2. And then we come down here, and we run that inner one again 5 times. Boom, 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 boom. Okay? So you can run a loop within a loop. You were probably saying to yourself, why in God's name would I ever care about that? And the reason you care about it is because in computer programming, this is how we access and traverse tables. This is how we access and traverse spreadsheet data, table data, grid data, because think about it. You can treat that inner and outer loop as columns and rows. So that outer loop is a row, okay? Boom. And then you go to the inner loop, 1, 2, 3. You go across the columns, 4, 5, 6, 7, till you're done. Then when you go to the outer loop, boom, that's row 2. Column 0, 1, 2, 3, 4, 5, and that way. Nested loops is basically how we deal with grid data or table data. Now that J, if we put a loop underneath that, you'd be dealing with K, but what that puts in my mind is X, Y, and Z. So now all of a sudden we're getting 3-dimensional coordinates, and we can deal with 3-dimensional shapes when we use our loops. And that's the way we would access that coordinate data, as if we had an I, J, and a K. So we could do that as well. You can have a 4th one and add time if you want to get into physics applications. So there's a lot of things you can do with the loops as far as this is concerned. And this is the way we basically keep track of multi-dimensional data. Back in the dinosaur days when I went to school, you would call lists arrays, and then you would have multi-dimensional arrays where you would be able to access things in a table. Okay? That's pretty much how every language does it. That's the way Python does it too, but you would access it. If you wanted to access everything in a grid, you would use an inner loop structure like this to do it. And it would allow you to go through all of the different columns along a row, then get the next row, columns along a row. And you can imagine how you could, the different ways that you could traverse your data if you did something like that. So keep that in mind. The second thing I want to show you is a little more interesting. What we've been doing so far, I apologize for keep saying I'm exhausted. I got caught up. This is a dumb story. I'm going to tell you anyway. I watched Narcos on Netflix. Yeah, it's that 2-season. I think there were 10 episodes a season on Pablo Escobar. And it was from the point of view of one of the American DEA agents who was there trying to arrest him in the 80s and the 90s. So I watched it. It was pretty good. And I was telling my buddies about it when we were out one night. And a friend of mine said, "Oh, you got to watch the other one." And I go, "What's the other one?" And it turns out that there are 2 different series on Netflix about Pablo Escobar. One is Narcos, which is the one I watched and the one that's getting a lot of critical acclaim lately. But there's another one that was produced in South America in 2012, and it was 74 episodes long, like 74 44-minute episodes, and it's in Spanish with subtitles, so you can't walk away from it. You have to sit in front of the TV and watch it, and I'll be damned if I can watch all 74 of them. And at first, the actors look cheesy, and the production is bad, and it was kind of corny in the beginning, but it grew on you. And at the end, I ended up watching the whole thing through. It was a lot more detailed, as you could probably imagine. 74 episodes. And Pablo Escobar was a nut. He was a crazy person. But it's an interesting story. It's like the last of the cowboy stories, because no one's ever going to get away with the nonsense he got away with ever again. But it was good. It was interesting. But I got home from the Rutgers game, and I started watching that, and I got zoned out. I'm tired right now. But you don't need to hear this. You need to hear about indefinite loops versus definite loops. We've been doing definite loops. I know my list is 5 items long, so I'm just going to go over it 5 times. What we just did with the nested loops. I know my outer loop is 3. I know my inner loop is 5. I know exactly how many times I'm going to run through that loop. Well, what if there's a situation where you don't really know when you want the loop to end, and you want that loop every time it iterates to check a condition to see what's going on? We're going to look at something like that. I'm going to create a variable. I'm going to call it char. I'm going to make it equal to the character y, and then I'm going to create a loop. And this is the kind of loop I'm going to create. I'm going to create a while loop. And I'm going to say while char is equal to y, keep running this loop. So I'm going to print loop, because I can't think of anything better to print. And then I'm going to ask for char again. I'm going to say input. And I'm going to say, do you want to continue? Okay. Now, input, I don't need to cast because I want a character. I'm asking for a character. And I'm going to say, do you want to continue? What's going to happen is I don't really need that space there. So character equals y. While character, remember it's equivalency, so I have 2 equal signs there. While character is equal to y, which it is, we just did it there, go into the loop. So I print the word loop, and then I ask the user, do you want to continue? If I say y, y gets put in the character variable. I go back up to the while, and it's still equal to y, so I drop down and I print loop again. So if I keep giving it a y, I'm going to keep printing loop. But the first time I give it something technically that's not a y, basically anything, I'm going to give it an n, but I could give it a g or an f or whatever, blah, blah, blah. And it would blow up, because if I give it an n, the variable character was going to be equal to n. So while char equal to y, it's not anymore. It's equal to n. So I'm just going to drop out. Boom. I'm not going to do it one more time either. When I get up here and it's not equal to n, that's it. I'm out of Dodge. All right, so let's see how that works. All right, do you? Of course I do. I think this is wonderful. Look at this. All right, so y. I'm still in the loop. I'm printing loop every time, only this time I give it an n, and I drop out. Nothing happens. All right, let there be something that happens at the end that happens only once, so you can see the behavior when it drops out. Didn't I save it? Invalid syntax. How did that get there? All right, done. Save. Probably put it there when I saved it. Yes. Oh, look at that, YU. It got YU because I typed it accidentally, and then it said the end, and I'm done. Okay. Now, we don't have to do it like that. Char equals Y, while char not equal to n. We can do it this way, too. Okay. So if I do this, and I say F5, do you want to continue? Yes. Yes, 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 yes. And you can see up here, I did it 4 times and went out. Here I did it twice. Here I'm doing it, what, 7, 8 times? It's indefinite. It's not a definite loop. I don't know how many times I'm going to go through it because the responses are always different. But now if I give it an n, I end. Okay? So now you've created the opposite condition. I can give it anything I want. It doesn't have to be a Y. I can even give it multiple letters. But if I give it that n, I'm going to drop out. All right? So that's how we do a while loop. You'll see as we move forward, and if you do programming later for gaming or for other things, game programs at the beginning, like when a game ends and it says, do you want to play again? That's a while loop. It's just a big while loop. A lot of games are just housed in a massive while loop, and at the end it'll say, hey, play again, and if you say yes, you go to the top of the loop. That's literally all that is. It happens all the time in games. While loops are used all the time. You test conditions. If the condition is the same, keep doing it. If something changes, get out, go do something else. So this happens, while loops are utilized quite a bit in programming. You'll get the hang of it. You'll understand when you're putting together logic, whether I just have a list, I want to iterate over it, or I know I need to do this 20 times, or the user or one of my formulas is going to change something. Let me do a while loop so I continue this behavior until I note that change. You're going to get the hang of it as we go through different situations and we do different kind of code. So that is a while loop. The very last thing we're going to do is near and dear to my heart. And that is, and you're going to see why when you get one of your assignments. This is, let me do something I'm going to be able to put together quickly. All right, I have a list. It's called the list, and it contains the items you see right there in front of you: 2, 4, 6, 8, 10, 300, 45, 67. And what do I want to do? I'm going to add those numbers together. So how am I going to go about doing that? Well, I am a man who knows how to create an accumulator. So this is a piece of cake. I don't need range because I have a list to go over. And what I'm going to do is I'm going to say cum equals cum plus I, and then when I drop out, I'm going to print cum. What is that going to tell me? That's going to tell me 442. Now, how do I know if that's correct or not? I can sit and add all these things up, but you know what? I can also show you something else. We can use the sum function on the list. It's kind of cheating because we could have done it before, and you'll see we're correct because both of them come up 442. You're going to see the reason I'm using an accumulator here at first, but the sum is a function. You can run that function on iterable lists. So anything that you can iterate over, strings, lists, different kinds of objects, you can use sum to sum up, but that is for another time. So now I want to add all those things up and I print accumulator, and that's great. But what if I wanted to add all of the items in this list until I saw 300, and then I wanted to stop and just print out the sum of everything up to 300, okay? Classically, what we've been looking at so far for I in the list does everything. Doesn't stop in the middle. You're always going to start here, and then you stop regarding the list at the very, very end. So we've got to try and find a way to determine when we get to 300, and then the harder thing, because we don't know how to do it right now, is when I hit 300, I want to stop. I want to, not loop anymore. I want to jump out and print whatever value I have. We can do that. And the way I'm going to do that with you is I'm going to teach you how to create what's called a Sentinel loop. The Sentinel is basically the thing you're looking for. Okay, that's called the Sentinel. And the way you set up a Sentinel loop is that you go along doing whatever it is you want to do for your logic until you see that Sentinel. And then when you see that Sentinel, you break out of the loop. Okay, there's a bunch of different reasons why we might do this. At first, I'm just going to do it. Sometimes you save a whole bunch of data and there's error codes and you want to stop at an error code, or sometimes you don't want to deal with something that's negative, so you go merrily along the list until you hit the first negative value or something like that. There's different reasons why we want to do that. But how am I going to add up 2, 4, 6, 8, 10 and come to a good number with that? So I got accumulator 0 for I in the list. Okay, so I grab the first number. What do I want to do when I grab the first number? Okay? Can you hear that contemplative silence? What are you going to do when you grab that first number? This is a Sentinel loop. So what do I want to do? I want to make sure that number's not 300, because I don't want to, if it's 300, I want to get out of there. So the first thing I'm going to do is I'm going to say if I is not equal to 300, what am I going to do? Well, then I'm going to act normally. Then I'm going to accumulate it, because I'm looking for 300, but if it's not 300, then I want to proceed. So the first thing I'm going to do is I'm going to see a 2. I'm going to come down here to I in the list. First item, 2. If I not equal to 300, well, that's true. So then I accumulate it, okay? And after I accumulate it, I'm going to go back to the top of the list. And then I'm going to go merrily along, grabbing my numbers until I hit 300. When I hit 300, if I not equal to 300, well, that won't be true. So I'm going to want an else condition to handle things when that's not the case, okay? Now the problem becomes this. What do I want to do? Okay, I've gone merrily along 2, 4, 6, 8, and added my numbers to an accumulator because they haven't been equal to 300. But then, when I get to 300, that if isn't true anymore, so I bounce to the else. What I want to do is leave the loop and print accum so I can get the answer that I'm looking for. What is the answer that I'm looking for? 6, 12, 20, 30. So the answer should be 30. Okay, but how do I do that? How do I break out of a loop that's going on? All right, the way you do that in Python is with the command break. Okay, you can see that idle turned it orange because it's a keyword. Break will crack you out of loops. Okay, break will crack you out of whatever current loop you're in. Now, this is a decision structure. So it's this loop up here, the 4i, that you're breaking out of. And that's what you want to break out of. So break, if you were in like a nested loop, break would only break whatever loop that it's in. This break right here breaks this for loop because the decision structure isn't a loop. But it'll break out of there, and then you'll print accum. Okay? If the programming gods are with us, it should say 30. And it does. Okay? So that I wanted you to be able to see a Sentinel loop, because there are ways to break out of loops when we really have to do it. And usually it's when we notice, a negative or something is greater than 5,000 or a particular number that we're looking for. It can be, even searching for numbers through a large list is kind of like Sentinel looping, because a linear search is searching for that one item. And when you find that one item, you break out. That's another interesting thing, is that later, if you kept an index on this and you broke out, you'd know exactly where that 300 was. You'd say, oh, that's sitting in the 5 spot. 0, 1, 2, 3, 4, 5. Yep, 5. And you'd know where to get it if you index the list and things along those lines. All right. So this is a Sentinel loop. This is how you set things up so that when you see a certain value, bloop, you get out of Dodge, and that way you would only add up the numbers before then. All right. All right. So I think that, actually, I don't want to do that anymore. I want to do this. And tradition demands that we do a grand finale. Look at all that. So up to the top, up to the top, up to the top. We first started looking at iteration with just a regular list, and we had, what did we have? 2 through 10 or whatever, and we squared it, and then we cubed it, and I showed you how you could do things with a code block down there. Then I started showing you things with range, how you could start with the 1. Usually you start with the 0 as a default, but you could change it to 1. Second part of the interval is the first thing you don't want, and then you can, set the increment to be whatever you want. You can even set the increment, set it to go backwards and set the increment for -3, and then you'll start 100, 97, 94 down like that. Then we actually solved a little problem. We actually took the numbers 1 to 300, squared them, put them in a list, and then we examined that list and found all of the numbers that were greater than 50,000. And when we did, we numbered them and we accumulated them. So when you get to the bottom, you figured out there were 77 of those bad boys, and that's the accumulation of all of them. Okay, so that was pretty useful. Then we looked at nested loops. You saw how we, with the I and the J, we handled sort of like a grid structure, and how you have the outer loop and then the inner loop runs inside of it, and then boom, you go to the outside again and you do it all over again. All right. Then we looked at, what do I want to do here? Yes. We looked at, actually, you know what? This loop is 2 kinds of loops. This loop is not just an indefinite loop where we use a while and we're looking for a certain condition, but it's also something called an interactive loop, because I'm the one providing the data right there. It's not like some formula is doing it or some other numbers are changing from somewhere else. If we wanted to, we could look up a web page. I could, use curl and grab nj.com and look for a certain term, and I could have that loop run until it saw the term that it was looking for. So that you'll see while loops used in that context a lot. But in this simple example to show you, I just did something silly like this. So this is interactive as well as being indefinite. So I'm going to get out of that, and then I'm going to show you the 30 because I did our Sentinel loop. Our Sentinel loop. All right. Now, do not fear, loops.py is going to appear in your Sakai resources, and all will be well. I am filming this super late on Saturday night. You're probably not going to get it till Sunday night, but I want to start getting you all of your resources because I want to get you everything before Thursday. And Monday or Tuesday, I'm probably going to do the Euler video for you. And when you get to that, you're going to see that that's really fun, because now you have loops. I mean, now this is it. This is the thing. You got to get to this point. This is a really good point in teaching people Python, especially, beginners in an intro course. I know most of you aren't beginners, but it's the first time you're seeing Python. Now we can actually do something. Now we have enough that I can use lists, I can use iteration, I know what to do with data and some things with arithmetic. I know how to use if-else, I know how to create that kind of structure so I can examine things and make decisions based on them. This is all pretty powerful stuff, and it forms the foundation of all computer languages. Now we actually have enough to go look at problems out there and say, oh, if I did that, I could set up my data this way, run over the list, 300 times and generate an answer and do different things along those lines. This is the point where we really, it's funny, a lot of what we're going to do from now forward is how we organize our code. You're going to see in Unit 3, we're going to deal with things called functions, and then we're going to deal with file I/O and modularity and libraries. A lot of that is organization and the way we organize our code. It doesn't really have to do with doing things and making decisions. That we're all doing now. We're getting the basics of that now when we learn about loops and iteration and sequences and things along those lines. So you're getting the tools. It's going to soon... You're going to get some interesting stuff to do. You're going to get 2 assignments this unit, and both of them are interesting to me, and you will find out why after you do them and hand them in. We'll talk about them. I will probably give you the homework assignments Monday or Tuesday. They're not, in this unit, they're not super long and they're not super hard. They require thought, okay? But you're not going to be writing miles of code to do the different assignments that we have to do. I don't know what tomorrow is going to hold, so I don't want to promise you a data sheet on the midterm project just yet, because that might not happen until Monday or Tuesday as well. What I should do tomorrow is sit down and get grades underway, because I need to grade your quizzes. I need to set up the grade book. I had somebody send in an extra credit point today and get it, so I thought that was pretty good. Read your slides if you haven't yet. Yeah, so things are moving along pretty well. This is going to be your second review video. You'll get the Euler one later in the week. You'll have your assignments, and Unit 2 should roll along in pretty good fashion. Remember, learning how to program is a paint job, okay? 3 coats. Your primer coat is when you spend the first 4 or 5 days reading the slides in the book. Now, you just took a quiz, you want to forget about Python for a couple days, I get that. But if it's Sunday night and you still haven't read the slides yet, you're screwing up. Because what you want to do is read the slides in the book as early as possible. Tinker a little, just get it on your brain so it can sit there and you can consider it. Then the second time you're going to want to look at all of that stuff is when you get the assignments. Then you can go say, oh, I remember how to do this because I read the slides here and I did this and I did that. Then you're going to hit those resources a second time. And then you're going to get that second coat, and that's going to help you remember even more. Then the third coat is at the end of the unit when you've already done the assignments and you want to brush up a little because you know you're going to have to take a quiz in a day or two. If you, and I know because I've been there, and I believe me, I was in your shoes 20 years ago, so I get it. But a lot of you are like, I don't have to do that. I'll wait till I get the assignments. Then I'll just go back in the book and the slides and learn what I have to learn to do the assignments. You could do that, but it's a crappy way to learn. You really want to read the resources, play with some exercises, do some stuff, and then in a couple, maybe, 4 or 5 days after that, then get the assignments. Then you can say, okay, now I've got a puzzle to solve, and then you can look for the different ways to solve that puzzle. All right, so the way I design things is so that you're hitting these things 3 different times. Because I know, especially with me, I benefit from repetition to no end. If you show me something the first time, I'm like, I don't get it. I need to see things a couple of times, and I need to see something working. And then slowly but surely it'll sink in, and you're like, And then by the 4th or 5th time, you've got it. You've got it down pat. And you'll see. That's the way it works. You're going to be shocked. Like I said it before, at the beginning of all the slides, I'm always going to list all the stuff you've learned to that point. And when we get to the end of this course, that's going to be 2 slides. And you're going to look at that list and you're going to be like, oh my God, that's a ton of stuff. But you don't realize it as you're learning it, but you're learning a lot of stuff. All right? A lot of you have gone through it before, I know, but what do you want to do? All right, I'm going to get out of here because I know this bad boy went over. This guy must have gone over crazy. Oh my God, 54 minutes. All right, so this has been a long one, but hopefully it'll be helpful. And remember, it's YouTube, so you can stop it or look here, look there. I'm going to get out of here. Look for the Euler video. Everyone's doing great in the course so far. Expect your grades soon, and you be good, and I'm going to get out of here, all right? All right, talk to you later. Bye.